Good afternoon. I am Pooja Bhanot, lecturing chemistry from Pandit Jagatram Polytechnic College, Hoshiarpur. Today I am going to discuss the topic that is ionic equilibrium and the concept of pH. First of all, we will discuss what is ionic equilibrium. So, what is equilibrium? Equilibrium is the state at which the concentration of reactants and products do not change with time. And another definition of equilibrium is the equilibrium may be defined as a state of process in which the properties like temperature, color, pressure, concentration of the system do not show any change with time. So, what is equilibrium? Equilibrium is that state in a process when the concentration of the reactant and product they do not change with time, even the temperature, color and pressure also do not change with time. So, equilibrium is always attained in a closed vessel. What are the types of equilibrium? There are two types of equilibrium. One is physical equilibrium, second one is chemical equilibrium. If the opposing processes involve only the physical changes, then the equilibrium is called physical equilibrium. So, what is physical equilibrium? That means there are only physical changes involved in that equilibrium. For example, the melting of ice in water, there is only the change in the phase from solid to liquid. So, such a equilibrium which is attained in physical processes is called physical equilibrium. What is chemical equilibrium? If the opposing processes involve chemical changes, then the equilibrium is called chemical equilibrium. For example, the reaction between hydrogen and iodine which results in the formation of hydrogen iodide is a example of chemical equilibrium, because there is the change in the composition of reactants and they are getting converted into a product whose name is hydrogen iodide. What are the terms which are used in ionic equilibrium? Electrolyte. An electrolyte may be defined as a substance which either in molten state or in aqueous solution can conduct electricity. So, what is an electrolyte? Electro means electricity, light means lysis, that means breakdown. Electrolyte, therefore, it is defined as that substance which in either in molten state or in aqueous solution conducts the electricity. So, what are the examples of electrolyte? They are acids, bases and salts. So, there are two types of electrolytes. One is strong electrolyte and second one is weak electrolyte. The electrolytes which are almost completely ionized in aqueous solution, for example, sulfuric acid and hydrogen chloride. Strong electrolyte is that electrolyte which is almost completely ionized. So, the important examples are hydrosulfuric acid and hydrochloric acid. What are weak electrolytes? The electrolytes which are ionized to a small extent, for example, acetic acid and ammonium hydroxide. So, one point which I am going to discuss here is that equilibrium is always attained in the weak electrolytes which are partially ionized or which are ionized to a small extent. So, equilibrium can be attained only in case of weak electrolytes. So, ionization of electrolyte in aqueous solution. The molecules of some compounds when dissolved in water they gets decomposed in two types of charged particles called ions. So, when the molecules of some compound they are dissolved in water, what they do? They get decomposed into two types of charged particles, and these charged particles are called ions. The ions which carry positive charge are called cations, while the ions which carry negative charge are called anions. So, the positively charged ions which are formed, they are called cations, and the negatively charged ions are called anions. Initially, very few molecules they get decomposed into ions. Then gradually what happens? The concentration of ions increases. When the concentration of ion becomes too high, then the ions reunite to form molecules again. So, what happens? Initially the concentration of ions is very less, but what happens gradually? The concentration of ions increases, and when the concentration of ions become too high, then what the ions do? They reunite to form molecules again. So, what happens then when first of all the molecules they are decomposing into ions, then at one concentration what happens, at what time some ions they are just combining with each other to form molecules again. So, at this stage that equilibrium is set up when the number of molecules which are breaking is equal to the number of ions which are combining to form the molecules again. The state of process is called ionic equilibrium, where the rate of forward reaction becomes equal to the rate of backward reaction. So, such an equilibrium which is formed between the unionized molecules and the ions is called ionic equilibrium. So, to explain the ionic equilibrium, Arrhenius was the scientist who gave the theory of ionization. So, what were the main point of this theory? That when an electrolyte is dissolved in water, when electrolyte dissolves in water, so what happens? It splits up into charged particles, and these charged particles are called ions. The process of splitting of an electrolyte into ions is called ionization. So, this process of splitting the electrolyte into ions is called ionization. So, what the second point he gave that the positively charged ions they are called cations, and the negatively charged ions they are called anions. So, third point which he gave, that is the total charge on cation is equal to that on of the anions, and the solution as a whole is electrically neutral. So, the main points of this theory were when the electrolyte is dissolved in water, then it splits up into charged particles, and these charged particles are called ions, and positively charged ions are called cations, and the negatively charged ions they are called anions, and the total charge on cation is equal to that on the anions. So, solution as a whole is electrically neutral. So, what other postulates he gave? He gave the ions present in solution constantly reunite to form molecules, and there exists a state of dynamic equilibrium between the ions and unionized molecules. So, I have given this equation. What is AB? This is the unionized molecule, and when it is dissolved in a solvent, then it ionizes to form A positive and B negative. So, I have explained this earlier also, that whenever a molecule is dissolved in a solvent, then it ionizes to form ions. So, first of all the concentration of ion is very less, but gradually it increases, and at certain stage the molecules ions recombine, they combine again and they form the molecules again. So, at this stage when the ions combine together to form molecule, then a equilibrium is set up, and this equilibrium is called ionic equilibrium. So, from this equation it is very clear that here the unionized molecule is getting converted into ions, and the ions they are combining with one another to form the molecules again. So, this arrow is representing a equilibrium where it shows that reaction is going in forward as well as backward direction. So, at equilibrium what happens? At equilibrium the rate of forward direction reaction becomes equal to the rate of backward reaction. So, the next postulate of Arrhenius was the properties of electrolyte, they are the properties of ions. That is, if we are considering electrolyte like acids and bases, then the properties of these acids and bases depend upon the concentration or the properties of the H positive ions and hydronium ion and OH negative ion, that is hydroxyl ion respectively. That means the property of acid depends upon the property of hydronium ion and the property of a base depend upon the properties of hydroxyl ions. So, the conductivity depends on the number of ions also. So, next postulate which he gave, that at moderate concentration only a fraction of total amount of electrolyte ionizes. The fraction of the total number of molecules of an electrolyte which ionizes on dissolution is called the degree of ionization. So, degree of ionization is the fraction of the total number of molecules of an electrolyte which ionizes or dissociates on dissolution, that is called degree of ionization. So, degree of ionization is it is represented by the symbol alpha, which we can show as the number of molecules which dissociate over the total number of molecules. So, what is degree of ionization? This is the fraction of the total number of molecules which ionizes. So, what are the factors which are influencing the degree of ionization? So, degree of ionization is basically influenced by the 5 factors. So, what is degree of ionization? I have explained it as the degree of ionization may be defined as the fraction of the total number of molecules which ionizes. It is represented by alpha. So, what are the factors? This is dilution, second factor is temperature, third factor is nature of solute, fourth factor is nature of solvent, and fifth factor is the presence of other substances. So, what is the effect of dilution? So, as we increase the dilution, the rate of ionization also increases. With dilution, I means that I am increasing the quantity of solvent. So, what is the effect of dilution? With the increase in dilution, the degree of ionization also increases. So, what is the effect of temperature? With the increase in temperature, the degree of ionization increases. So, nature of solute. So, I have already explained to you that there are 2 types of solutes. One is strong electrolyte and second one is weak electrolyte. So, the strong electrolytes like sulfuric acid, hydrochloric acid, they have greater degree of ionization because they ionize completely, while the weak electrolytes, they have less degree of ionization as they are ionized to a small extent or partially. What is the nature of solvent? So, solvent, with nature of solvent, we consider the dielectric constant. So, what is dielectric constant? Dielectric constant is the capacity of the solvent to weaken the forces of attraction between the oppositely charged ions of the solute. So, whenever a solute is dissolved in a solvent, the solute is composed of 2 oppositely charged ions, that is cations and anions. So, there is a strong force of attraction between these ions. So, what the solvent do? Solvent just used to weaken these forces of attraction. So, that capacity to reduce the or weaken the forces of attraction between the oppositely charged ions is called dielectric constant. So, any solvent which is having high dielectric constant will cause greater degree of ionization. For example, if we consider the example of water and alcohol as a solvent, so the water is having high dielectric constant, that is near about 80, therefore, it causes greater degree of ionization as compared to that of alcohol. So, the next fifth point is the presence of other substances. presence of other substances reduces the degree of ionization of a electrolyte. For example, the presence of ammonium chloride causes the decrease in the degree of ionization of ammonium hydroxide. So, I have explained you all the 5 factors which influences the degree of ionization. So, what are those factors? Dilution, temperature, nature of solvent, presence of other substances and the nature of solute. Next is other related topics. So, next after discussing this equilibrium, then the types of electrolytes and this one the fact what is degree of ionization, what is Arrhenius theory and what are the factors which are influencing the degree of ionization. I am going to discuss here the next, that is ionic equilibrium in aqueous solution, that is derivation of Ostwald dilution law. So, K is equal to C alpha square, which is the mathematical representation of Ostwald dilution law. In the next slide, I am going to derive this relationship. Next point which I am going to discuss is the ionization of water. Next is the concept of pH. Then I will try to solve some numericals based on pH. So, what is ionic equilibrium in aqueous solution? This is the derivation of Ostwald dilution law. So, let us consider that there is a weak acid, for example, AB is a weak acid. Let us suppose AB, it can be acetic acid because acetic acid is a weak acid. So, I have already explained what are weak acids. These ionizes partially or to a small extent. When this acid is dissolved in water, it dissociates into A positive, that is cation, and B negative, that is anion, and the following equilibrium is obtained. So, what happens whenever this is dissolved in water, then AB dissociates to form A positive and B negative, and A positive and B negative also have a tendency when its concentration increases to combine with one another and then forming the electrolyte again. So, what I am supposing here that initially the concentration of AB electrolyte is C mole per liter, that is C, and the concentration of cation and anion is 0 and 0, because initially the reaction has not been started and the concentration of electrolyte is taken as C while the concentration of product is taken as 0 0. So, what happens at equilibrium? At equilibrium, let us suppose that C alpha amount has been dissociated, C alpha amount has been converted into cation and anion. So, what I am doing here, that C minus C alpha. So, taking out common C, then we are getting that C 1 minus alpha. So, I have decreased C into alpha. Alpha is the degree of ionization that I have already explained, and C is the molar concentration. So, I have taken initially the concentration of electrolyte C, then decreasing the amount, that is C alpha from C, then taking out C as common. So, what we have obtained, that is C 1 minus alpha. So, what has been obtained as a product? C alpha amount of cation and C alpha amount of anion has been formed. So, it is very clear from this equation. So, now I am going to write the equilibrium constant. So, the equilibrium constant is also known as dissociation constant. What is dissociation constant? Dissociation constant is the product of the concentration of products over the concentration of reactant. So, here in the last slide, what are the products? Products are A positive and B negative, and what are reactant, that is AB. So, what I am taking? I am taking the ratio of these, that is product of concentration of product over concentration of reactant. So, the molar concentration of cation is taken in this square brackets, that is A plus brackets and B negative brackets, that it means this is the product of molar concentration of product over the molar concentration of reactant, that is AB. So, the at equilibrium, what is the concentration of A plus, that is C alpha, what is the concentration of B negative, that is also C alpha. So, C alpha into C alpha over the concentration of electrolyte, that is C 1 minus alpha. So, then we are solving this equation, what we are getting from this, that is C alpha square over 1 minus alpha. So, this expression we have got, that is K is equal to C alpha square over 1 minus alpha. So, for a weak electrolyte where the degree of ionization is very less, so it is very less in comparison to 1. So, in comparison to 1, the alpha can be neglected. So, if we are neglecting alpha, then what we are getting in the expression, then 1 minus alpha, that is alpha we are neglecting, therefore, it is equal to 1. Then K is equal to C alpha square. So, what expression we are getting? This is called the Ostwald dilution law, where the alpha is equal to under root K over C, that is inversely proportional to the square root of concentration. Degree of ionization is inversely proportional to the square root of concentration. Alpha is equal to under root K over C. This expression we are getting. This expression, according to this expression, this is for a weak electrolyte, the degree of ionization is inversely proportional to molar concentration. This Ostwald dilution law is only applicable on weak electrolyte, because in strong electrolytes the alpha is equal to 1. So, 1 minus 1 will be equal to 0. The answer will come in infinity. So, this is not applicable on strong electrolyte, this is only applicable on weak electrolytes. So, from this equation it is clear that degree of ionization increases on dilution. So, degree of ionization, what it does, it increases with increase in dilution. Next is the self ionization of water. So, we know that the pure water is a poor conductor of electricity. This shows that water is a weak electrolyte and dissociates to a very small extent. So, it is a weak electrolyte. So, equilibrium can be established in case of water. So, what happens when water ionizes? It forms hydroxyl ion and H positive ions. So, the equilibrium is established, and self ionization, water molecule in the presence of other water molecule also ionizes to form hydronium ion and hydroxyl ion. So, this equilibrium applies to pure water and any aqueous solution. The chemical equilibrium constant, that is K EQ, for this reaction is given by, I have already explained you how to write the equilibrium constant. You have to write the product of molar concentration of product over the molar concentration of reactant. So, in the first equation the product is H positive and OH negative, that is you have to write in the numerator, and H2O is written in the denominator. So, let us write the equilibrium constant for these two equations. Then K equilibrium for this reaction is given by H positive into OH negative, that is product, over that of reactant, and for second equation this is hydronium ion and OH negative ion, they are the products and the H2O is the reactant. As the water is ionized to a small extent, therefore, the concentration of unionized water is taken to be constant. So, it does not vary. So, it is taken to be constant. So, what we are getting from this equation, K into H2O whole square, that is constant, is equal to hydronium ion into OH negative ion. So, equation 2 may be written as hydronium ion, that is molar concentration of hydronium ion, these brackets means that this is the molar concentration of hydronium ion, and OH negative ion, that is equal to a constant into H2O whole square. So, H2O whole square is also taken to be constant, because the water ionizes to a small extent and the concentration of unionized water is taken to be constant. So, therefore, this is constant into constant. So, we are getting another constant, that is equal to Kw. So, this is called the ionic product of water. So, here we are getting expression that ionic product of water is represented by Kw, and it is equal to what product of the molar concentration of hydronium ion and the molar concentration of hydroxyl ions. It must be noted that the ionic product of water is constant only at constant value. Its value at 298 Kelvin is found to be 1.008 into 10 raised to power minus 14. So, Kw is equal to 1.008 into 10 raised to power minus 14. So, what is the effect of temperature? The ionic product, that is Kw, increases with increase in temperature. This is because with increase in temperature, the degree of ionization of water increases. So, ionic product also increases. So, hydronium ion and hydroxyl ion concentration in pure water at 298 Kelvin is, let us consider the self ionization of water, that is H2O plus H2O, that is giving hydronium ion and hydroxyl ion. For any degree of ionization, we will have the concentration of hydronium ion is equal to the concentration of hydroxyl ion. So, but at 298 Kelvin, I have already derived that the ionic product of water, which is represented by Kw, is equal to the hydronium ion concentration into the hydroxyl ion concentration, which is equal to 1 into 10 raised to power minus 14. For any degree of ionization, what we are taking? We are taking that the concentration of hydronium ion and hydroxyl ion is equal. So, we can write this equation as hydronium ion into OH negative ion as hydronium ion square is equal to 1 into 10 raised to power minus 14. So, taking out the square root, what we are getting, that is hydrogen ion concentration is equal to 1 into 10 raised to power minus 7 mole per liter. Thus, in pure water at 298 Kelvin, hydrogen ion concentration is equal to OH negative ion concentration is equal to 1 into 10 raised to power minus 7 mole per liter. If some acid is added to pure water, so what happens? I have explained here the neutral water, the hydronium ion concentration is equal to hydroxyl ion concentration, which is equal to 1 into 10 raised to power minus 7. But if we are adding acid, that means we are increasing the concentration of hydronium ion. So, when the concentration of hydronium ion exceeds 1 into 10 raised to minus 7 mole, then Kw, as we know that Kw is constant. So, what we are getting here, that concentration of OH negative ion decreases and may be calculated as, I have already explained previously that the product of molar concentration of hydronium ion and OH negative ion is equal to Kw. So, we are taking that expression, when the concentration of hydronium ion increases 1 into 10 raised to minus 7, then the concentration of OH negative ion can be calculated by applying this relation, that is OH negative ion is equal to Kw over hydronium ion. If some base is added to pure water, then what happens? Then hydroxyl ion concentration increases from 1 into 10 raised to minus 7. Since Kw is constant, then the hydronium ion decreases. So, it can be calculated by applying following relationship, that is hydronium ion is equal to Kw over OH negative ion concentration. So, what we have got in general, that for acidic solution, the hydronium ion concentration is greater than hydroxyl ion concentration. For basic solution, the hydronium ion concentration is less than hydroxyl ion concentration. For neutral solution, hydronium ion concentration is equal to hydroxyl ion concentration. So, next I am going to explain the concept of pH. This was given by the scientist, that is Sorensen. So, as we have got the Kw, that is ionic product of water, is equal to the product of molar concentration of hydronium ion and hydroxyl ion. So, from this equation holds good to all the solutions, that is neutral, acidic as well as basic. So, from here we can get the concentration of hydronium ion. So, what is the this concept was given by Sorensen. What he gave, that symbol pH has been taken from Danish word, that is potens the hydrogen ion, which means the power of hydrogen ion. So, the pH of solution may be defined as negative logarithm of hydrogen ion concentration. So, pH is equal to minus log of hydronium ion concentration, which is equal to the log of reciprocal of hydronium ion concentration. So, pH concept was obtained from the relationship, that is Kw is equal to product of hydronium ion concentration and hydroxyl ion concentration. So, what does pH means? pH means the potence the hydrogen ion, which means the power of hydrogen ion. So, the pH